All right, welcome back, everyone. Today we're going to talk about logarithmic functions, and this will be the first part of this section. So in this section, you're going to learn the definition of a logarithmic function and its relationship to exponential functions. We're going to talk about how to determine a logarithm without your calculator, and then how to convert an equation between exponential and logarithmic form. So a logarithmic function is the inverse of an exponential function. We talked about inverse functions first, then we talked about exponential functions. A logarithm is just the inverse of an exponential. For example, if an exponential function is given by y equals a to some power x, then we would start to find the inverse by just switching x and y. And I wanted to point out here that we refer to a as what's called the base. So I'm referring to the base, I'm talking about that number a. If we switch x and y in this equation, then we get x equals a to the y. However, this is somewhat inconvenient, and so we write the function in a different way. If we solve for y, the basic logarithmic function is given by y equals log base a of x. And what this basically says is what power do you raise a to get x? And that number is equal to y. If you look back at our equation when we were going for the inverse, x equals a to the y is going to tell us what power we have to raise a to get x. And so it's the same thing. We're just saying what power do you raise a to get x? What power do we raise the little base to get the number x? For example, if we have log base 3 of 9, that's saying what power do you raise 3 to get 9? Well, 3 to the second power is 9. And so log base 3 of 9 is just equal to 2. And what power do you raise 3 to get 9? Well, that's just equal to 2. So when we write a common logarithm, and there's no base there, so it just says log, that implies base 10. So what power do we raise 10 to get whatever number it is? Okay, so if there's no base written, assume that it's 10. Otherwise, go with the base that's written there. So let's try some examples. We want to solve these common logarithms by just asking ourselves, what power do I raise the base to get the given number? So we have log base 4 of 64. So the question is, what power do you raise 4 to get 64? Well, 4 to the third power is equal to 64. So what power do we raise 4 to get 64? Well, the answer is 3. Similarly, log base 5 of 25 says what power do we raise 5 to get 25? Well, 5 squared is 25, and so the answer is just 2. And finally, log base 12 of 1, what power do we raise 12 to get 1? Well, the only power that we can raise anything to get 1 is 0. So what we get from these equations is essentially 5 squared is equal to 25, and 12 to the 0 power is equal to 1. Let's try some more. So remember that negative exponents can be moved across the division line, right? So x to the minus 1 is the same thing as 1 over x. Also, roots are the same as fraction powers. So a square root is just x to the 1/2. The cube root is x to the 1/3. Right? The fifth root of x squared is x to the 2/5. And so let's start with our first example. We have log base 16 of 4. And so we want to know what power do we raise 16 to get 4? Well, 4 is the square root of 16. And so 16 to the 1/2 power is going to be equal to 4. And so log base 16 of 4 is just 1/2. What power do you raise 16 to get 4? Well, that power is 1/2. Looking at the second problem, log base 2 of 1 over 8. What power do we raise 2 to get 1 over 8? Well, 2 to the third power is equal to 8, which means that 2 to the negative 3 power is going to be equal to 1 over 2 to the third, which is 1 over 8. And so what power do we raise 2 to get 1 over 8? Well, the answer is negative 3. And finally, we have log of 1,000. Remember that if there's no base, the base is understood to be 10. And so this is the same thing as log base 10 of 1,000. And it's saying, what power do we raise 10 to get 1,000? And that's going to be the third power. So 10 to the third is equal to 1,000. Moving along, as we saw in the previous section, that number e is really, really important. So we define a logarithm based on e, and it's called the natural logarithm. And we will write it as ln of x. Okay? But remember that it just means the same thing as log base e of x. Okay? Those two equations mean the same thing. So we just shorten it by writing ln of x, and that implies that the base is e. Now, logs and natural logs have some particular properties. So, for example, log base a of a to the x is equal to x. I'm not going to go through all of these, but I'm going to try to explain how one works, and you should understand then how the rest work. So log base a of a to the x is just saying, what power do we raise a to get a to the x? Well, obviously, whatever power we raise a to get a to the x has to be x. Similarly, the natural log of e to the x is just asking, what power do we raise e to? Because remember, the base for natural log is e. So what power do we raise e to get e to the x? Well, that's just x. And notice here I have this one identity in red. We're going to use that a bunch later on in the next few sections. It's very, very useful. So just remember that. So refer back to these identities if you have to use them. So let's try some more examples. We want to find the log of 0.01. Well, the log of 0.01, that's the same thing as the log of 1 over 100. And this is asking, what power do we raise 10 to? It's log base 10 of 1 over 100. What power do we raise 10 to get 1 over 100? Well, 10 to the second power is 100. So 10 to the minus 2 is going to be 1 over 100. And so the answer is just minus 2. If we have the natural log of 1 over e, remember we can move numbers into the denominator and make their exponents negative. This is the same thing as the natural log of e to the minus 1. And what power do we raise e to get e to the minus 1? Well, that's just minus 1. That goes back to the identity we just used. The natural log of e to the x is just x. So the natural log of e to the minus 1 is just minus 1. And we can do the same trick on the last problem. The natural log of e cubed is just 3. What power do you raise e to get e to the third? Well, it's just 3. All of these can be checked, or all of these examples can be checked by just plugging them into your calculator. So if you cannot figure out how to change these things around, how to make 0.01 into 1 over 100, or how to make 1 over e into e to the minus 1, then just plug those things into your calculator. Done correctly, you will still get the same answer. And this is one way to check and make sure that you're doing logs and natural logs in the calculator correctly, which we're going to practice some in the next section. So one other really important thing about logarithms and exponents is that you can write their forms in different ways. And you've seen that in the past few examples that I've done. But this time we're going to actually do it intentionally. Because of the relationship between exponentials and logarithmic functions, we can basically just interchange the way these equations are written. It makes for solving equations much easier. So to switch between the two, you just have to remember which one's the base and which one's the exponent. And the number part will be the third piece. So here I have it color-coded. But if you have y equals a to some power x, and we want to rewrite that in logarithmic form, then it would be the exponent x equals log of the base a, the number y. You will see later how useful this is in solving equations, and we'll have to use this in section 5.5. But for now, let's just get some practice switching between the two. So first we want to convert these following equations from exponential to log form. So we have, at first, 10 to the 5th is equal to 100,000. So in this case, the base is 10, the exponent is 5, and the number part is 100,000. If we want to rewrite this in log form, we want to put the log of the base, which is 10. We know the exponent, 5, is equal to the log base 10 of the number. And so this would be our equation. All we did was switch the order around and toss a log in there. Log base 10 of 100,000 is equal to 5. Remember, it's just like saying, what power do you raise 10 to get 100,000? Well, that's equal to 5. Let's do the same thing for the second equation. We have e to the 4.3 is equal to 73.7. Oh, one thing I wanted to point out was the previous problem. We could have just as easily written this as 5 equals the log of 100,000. Remember that for a common log, we don't have to include the 10. Base 10 is understood. Now for this problem, we have base e. Okay, our exponent is 4.3, and the number part is 73.7. And so the exponent, 4.3, is equal to log of the base of the number. So we can simplify this just a little bit. Log base e is just the natural log of 73.7. Finally, I'm going to go to the next slide. We have r cubed is equal to 125. And we want to rewrite this in logarithmic form. The base is r, the exponent is 3, and so what we get is 3 is equal to log base r of 125. And that would be our equation in logarithmic form. So let's try some more examples. This time we want to convert the logarithmic equations into exponential form. So starting with the first one, we have log 0.001 is equal to negative 3. Remember, if there's no base, it's understood to be 10. So in this case, we have the base is 10. When we're looking at log expressions, the exponent comes after the equal sign. And so this is 10 to the minus 3 equals 0.001. And that would be your exponential form. Number 2 is very similar. The natural log of 2 is equal to 0.693. In this case, our base is e. Then the exponent comes after the equal sign, so we get e to the 0.693 is equal to 2. For our third equation, we have log base 2 of 8 is equal to 3. In this case, our base is 2. Remember, the exponent comes after the equal sign, so 2 to the third power is equal to 8. It may not be as clear when you're converting from exponential to log form, but when you're converting from log form to exponential form, you should see that you could check these answers just by plugging them in a calculator. Okay, and especially this last one, 2 to the third power is definitely 8. If you rearrange that in the wrong way, you would see that those two sides weren't equal. So let's do the last one on the next slide. And we've got log base p of q is equal to negative t. In this case, p is the base. Remember, the exponent comes after the equal sign, so that's p to the minus t. It's going to be equal to q. So we're just rearranging. We're not solving anything. We're just rearranging what these problems look like, either in log form and exponential form. Okay, this will be really important in just a few sections. So at the end of this lesson, you should be able to solve common logarithms without a calculator. And you should be able to convert equations between exponential and logarithmic form.